What's up guys? In this video we're going to deploy a NestJS API to AWS. We're going to see how we can create an EC2 instance and SSH into it and transfer files from our local machine to the server. This is going to be the first video in my new NestJS and AWS series, and I'm going to assume that you're brand new to AWS. So we will need to quickly set up and use IAM to create a user. If you're already familiar with the basics of AWS, feel free to skip ahead to the timestamp. So basically, we're going to need to navigate to this awsamazon.com, and this is where we can create our root account. So just a heads up, you will need to put in your credit card. We're going to stay in the free tier for everything. They have a very generous free tier. This is AWS, the sign up. But after you sign up, you can go to aws.amazon.com and you can just go ahead and you can sign in. And basically at this stage, you have the option between signing in between a root user and an IAM user. We're going to sign in as the root user because when you create your account, you only have the root user to start off with. And I've actually set up multi-factor authentication on my phone. So basically, if you have an application like Google Authenticate or something like that, it just adds an extra layer of security. So you can set that up, and I'll show you where you can go about setting that up. But I'm just going to type that in, my code from Google Authenticator. And now we can see that I'm logged in as a root user. So when you first log in, this is the console, and AWS is a huge platform. Basically, there's services for everything you can think of. So just to have a quick look at the console, in the top left here, you can see that we got the service finder. So let's say we want to put our NestJS application on the server. The server and the most popular service is the EC2. So you could go to the EC2 section, click on there, and then you can easily set up a server. And that's true with all of the services. So you can see that you've got your recently visitors here. So one thing I like to keep on my dashboard is the billing and cost management, and making sure that's in the $0 range. There's also IAM, which we're going to take a look in just a moment. That's the identity and access management, and that's where we can go ahead and set up users. And you'll notice in the top right here, we see that we're logged in. Now, as the root user, you'll see you'll be logged in as the root user, and you can see the account ID. We're going to log on to another user in just a moment, and we'll see why when we look at the IAM section in just a moment. But the other thing I want to point your attention to is the region. So currently it says, and by default, I'm in US East North Virginia. So the thing to note about regions is basically a region is just a cluster or a group of data centers. So for example, I will choose Sydney, Asia Pacific. And we can see that there's 3 different continents there. Oh, sorry, we've got the one continent, but 3 different countries within the continents. So in the Asia Pacific region, there's 1, 2, and 3, Sydney, Singapore, and Tokyo. So if I click on Asia Pacific Sydney, they'll have a code of AP for Asia Pacific, and then Southeast 2. Region is also made up of availability zones, or AZs, so you'll see that. Right here, you'll see AP Southeast 2, but a region usually has 3 availability zones, and that's just so that between each other, you have ultra low latency, and they're separated in case of a disaster. Because deploying to the cloud, one of the main benefits of it, amongst many, is the reliability and the high availability of your application. So there's lots of disaster relief situations and high speed between the availability zones. So just to talk about an availability zone a little bit more, the region here is AP Southeast 2. That's the region. And the availability zone will be, say, AP Southeast 2A or 2B or 2C, because there's usually 3. So that just makes sure that if something happens to one of the spots, your application will still be running, because the other availability zone probably hasn't handled or been situated with a disaster. And just to touch on like how you actually go about choosing the region, you can do that by, well, the most obvious choice would be your customers. If you know your customers are in a certain region or multiple regions, you would choose those, and you can deploy to multiple regions and stuff like that. But the thing to note with that is not every region has the availability to all of the services, so you might need to choose a popular region. The main services are available in most regions, but if you have a very specific niche service that you need to use or something like that, you might want to check the availability of the service. Also, the pricing, it varies region to region because it's a global company and they have different costs in different countries. So you might want to keep the pricing in mind. And another thing to keep in mind is maybe, you're working with the government, or you need to keep your data bound to a particular region. And in that case, you might want to choose a particular region based on those sensitivity requirements. So just to mention, before we get started, is the shared responsibility model. And basically what it is AWS is responsible for the infrastructure and the security of the cloud, whereas the developer is responsible for their system and the security in the cloud. So for example, AWS, they're responsible for making sure the services are highly available and secure, whereas the developer, they're more responsible for ensuring they've set up the application security, so authentication, they've set that up properly. And that should be pretty obvious, but they do have a naming for this shared responsibility model. So with that out of the way, let's go ahead and create a user. So we can go to the IAM dashboard here, and you could search it in the bar at the top. So by default, we are on the root account, and the root account, it shouldn't be used because it has permission to do everything. The idea is if you're an organization, let's say you're the CTO of the organization, you have a bunch of people under you, let's say, or you have groups that you work with and that you could be part of yourself as well, that have different goals in mind. So you might have the front-end developer group, you might have the back-end developer group, or you might have a developer group and an operations group that set up the infrastructure and all that sort of stuff. And basically what we want to do is we want to follow what's known as the least privilege principle. And what that means is basically you give the users the least amount of privileges or the ability to create services, because these services cost money, and you want the groups or the users in the groups, they don't necessarily have to be in a group, but they usually would be in a group, to have the access to only what they need to create. What we want to do is we want to create a user. So I am on the Identity Access and Management dashboard. And if I go ahead and click on users, we can see that there are no users, just this root user I'm logged in as. So what I'll do is I'll click on create user, and let's just give myself a user name. So I'll say John Dev AWS, and then I'll go ahead and I'll click provide user access to the AWS management console. So I want to create an IAM user. Now it says specify user in Identity Center, that's recommended, but the thing to keep in mind is I am the root user, but I am also just demonstrating what it's like to be a user. And you do usually want to just be logged in as a user, not the root user, because just following on with the least privilege principle. Even if you are the user itself, it's often better practice to sign in as another user. And usually you'd limit the different things you could do there just so you didn't make any mistakes or anything like that. Which means creating services you weren't meant to. But of course, if you are the user, it doesn't really matter. But just to show you how you do things properly, if you were to auto-generate a password for the user, basically that is for when you're creating a password for somebody else, or you could use it for yourself as well if you want to auto-generate a password. But usually you'd use that if you're the users must create a new password at sign-in. So you auto-generate a password, a user has access to that, and then you get them to create a new password at the next sign-in. But we don't want to do that since we are the user. So I'm just going to choose a custom password here. So I'm just going to type in something random here. And then we're going to click on next. So I'll just save that there. So basically, we want to add the user to a group. Now, if they're a developer, we might create a developer group. If they're in the operations team, we might put them in the operations group. And then we can choose a policy, which basically means the things that they have access to. And that's just composed of a JSON file. And it points towards different strings which contain the particular service and the resources and the actions that they can perform. So usually you'd give them the least privileges, but since this person's me, I'm just going to create an admin group. And the very first option is administration or administrator access. So I'll create this admin group here. And then I'll just go ahead and I'll click next. And then we can see the review option here. Tags are everywhere in AWS. You can imagine that AWS, because it's such a big platform, let's say you're creating multiple applications or even a really big application with multiple features within it, you might want to tag that. And you might want to tag it across teams as well. Like how you tag it, it's up to you. So for example, you might tag it developer or operations, or you might tag it by feature, like authentication or analytics or something like that. And that just means when you have a whole bunch of services created, you can easily find it by looking at the tag. But I'm not going to do that because I'm doing this more for demonstration purposes. So I'll just go ahead and create that user there. And you can see that we've got this console login here, and it points us towards, a randomly generated number and the sign-in console here. So we can actually make that a little nicer. And if we just return to the users list, it says you haven't viewed or downloaded this user's password. Oh yeah, so we want to download that as a CSV file. So we have the credentials handy and we don't lose them or anything like that. That way we can sort of have we can see the user, because you can imagine if we have lots of users, basically, like let's say we have 10, 20, 30 people working for us, it's just a way we can sort of monitor all of those and have those in a centralized spot. So you want to save that somewhere on your computer and not lose it. And basically what we want to do now is we saw that we had that link there, this sign in URL. So I'm on the dashboard in IAM. And we have this link here, but just to make it a little nicer for our people developing, we can create an alias. So you'd probably call this your organization name or something like that. I'm just going to call it John-Dev-AWS. And I'm going to create this alias. So now that we have an alias to go to and we have a user, what we can do is we can actually just sign in as that user. So you can't sign into two in the same browser, but what we can do is we can open up a tab in incognito mode. So let's just go ahead and do that. And just to wrap up on the those policies we were just seeing there, we'll have a look at it in a moment. But just to mention, you can put the policy on a group, and if a user is in the group, they'll inherit those group policies. If the user's in multiple groups, they'll inherit the permissions from all the groups that they're in. And it's also possible that a user's not in a group and they have specific permissions. So this could be an inline policy. So when creating a user from the root, we just saw that we can set the password and the min, but we didn't see this, but there was an option there where you could set up the password policy. So you could, as the administrator or the root user, you could say, well, we want your password to be a minimum length or a minimum strength, so special characters. And then they can also expire at certain times if you want to regulate the security of your users or allow them to change them themselves or not. So you can have control over all of that. But with that said, basically what we want to do now is we don't want to create services as the root user. We want to create services as the user that we just created. So we see that now we've created this alias. We can click this link here, and this will allow our users to sign in. And when I say users, I mean like our employees or our people in our team, not our application users. We can just go ahead and go to that URL there, and then it will automatically fill in that account ID or account alias. And for the IAM user, I've got this John Dev AWS, so that's saved for me there. So you can go ahead and just type in your password. You can remember this account if you want, and then you can go ahead and you can sign in. So likewise, what you will notice is you will have the email address at the top right rather than the root name. That's how you can distinguish if you're in the root account or your IAM account. And it also has this IAM user here. So you definitely want to be using your IAM user, not your root account. And just to see that we are selected for the Asia Pacific Sydney region, you choose that based on how we mentioned before, what would be best for your situation. So now that we have a user, let's go ahead and create an EC2 instance. So for this, we can just go ahead and go to EC2. So one thing you'll see here is there's a whole bunch of errors, and that just means we probably haven't set up the right permissions. So let's just go to our user groups, and we can see that there's 0 users in here. So let's just go ahead and click on admin here, and we can see that there's no users in here. So if we click on users, we must have forgot to add the user to the group. So let's just go ahead and click on this user and click on groups, and we can go ahead and add the user to the admin group. So we'll add the admin, that user to the admin group. So now if we go back over to the EC2 console, those errors have gone away, and then we can go ahead and we can launch an instance. So I'm going to call the instance NestJS API, And I'm going to select the Ubuntu OS image. So this is an Amazon machine image, and I've selected a free tier eligible one. I would recommend using some sort of Linux distro, whatever you're comfortable with. Amazon Linux is also pretty good, but perhaps your Ubuntu is probably the most common Linux server for, DevOps deploying your server. So I'm going to go ahead and use that. And the thing to note about Amazon machine images, they're basically, as it says here, they are an operating system, so usually a Linux one, an application server, and applications. So basically it's just a way to, let's say you have to create multiple EC2 instances. This is just a way to automate all of the steps that we're just about to do for configuration. So rather than clicking through all the boxes and pre-installing stuff and getting all the software up and stuff like that, you'll have your own AMI and you can use that. And you can actually sell these on the store if you want, if you come up with a real sophisticated one. But yeah, we're just going to have our NestJS API here. We're going to use Ubuntu. We're just going to choose the standard 64-bit in the free tier. And we're going to choose the T2 micro. So the instance type, that's just basically what the computer is. And I'm just going to select the free tier eligible one. So by default, it's just the T2 micro. And you can see, like, basically the more money you pay, the better compute power you'll get. What we want to do is, because we want to deploy our NestJS server here, what we want to do is we actually want to get the files from here into the instance. So what we want to do is we want to be able to SSH into the server. And to do that, we need to generate a key pair. So there's a private key on the server, and then there's a public key, and which is, and then you can send through, like, you can log in locally on your computer. You can put your private key that you have, your public key, and send it to the server, and the server will verify that through the private key, which will match your public key. It won't match it, but it'll there'll be parts of the private key that match you to the public key, along with a bunch of other private stuff that should only be on the server. So what we can do here is we can just go ahead and create a new key, and I'm just going to call this NestJS. I'll just call it NestJS. So you can call it whatever you want. And basically you can choose your encryption algorithm. I'm just going to go with the RSA encryption algorithm. And it's going to generate a .pem file. So I'm going to go ahead and do that. Unless you're on older version of Windows, under 10, you can use the PPK. So I'm just going to go ahead and create that. And then I'm just going to save it in, let's see here. I'm going to save it in code, and then EC2 simple, which is the folder I've got. And I'm going to save it next to my API. So you can save this in a secure spot wherever you want. But essentially where I've saved it is I'm going to have my NestJS API. I'm going to have my keys here. So with that out of the way, what we can do is we can look at the network settings thing here. And what we're going to do is, since we've created this key pair to be able to SSH in, we're going to allow SSH traffic from anywhere. That's clicked by default anyway, but basically if you're only going to log in from a specific IP address, you could put in a custom IP address, or you could put in your IP address, or you could put anywhere. I will choose anywhere, and you probably would use anywhere, perhaps. If you had like a VPN and your IP address changed, or even if you yourself wanted to go to a different computer or a different internet connection somewhere else and then log through SSH. So I'm just going to put that there. And the thing to note is we want to actually allow HTTP traffic from the internet. So to get HTTPS, you actually need to buy a domain name and get a SSL for that. Amazon, they have, I think it's like a domain registry somewhere, so you could buy it through Amazon, and then you can get the SSL easily through that, and then you're all in the same area. Or you can also get it from somewhere else and port it over. But we're not going to do that. We're just going to allow HTTP traffic. So we can see configure storage. We're just going to keep all that the same. So when you create a EC2 instance, it comes with storage. And the thing to keep in mind about storage is you can either attach some additional storage, but you'd have to set that up, or you can use the default storage. And the thing to note is if you terminate your instance, you will actually lose that storage. So there's ways to go about not doing that, but we'll look at that in a future video. And then if you click on advanced details here, we're not going to look at much of this. This is just advanced details here, but we're going to go down to user data. And what user data is basically, like I mentioned before, if you're creating multiple EC2 instances and it has all these same configurations, you might not necessarily want to go for this whole menu and select everything all over again and, you know, launch it all over again. Like for example, you might want to install, and we'll do this, we want to install Node onto the server. And then maybe we'll make a directory as well. And then that way, when the EC2 instance boots up, this is called bootstrapping, where the commands that we write here, they'll run once and once only. So basically to do that though, we're just going to have this shebang or hashbang /bin/bash, because the EC2 instance that we create with Ubuntu, we're going to want to create a shell script which will point to the bash executable on the Linux distro. So that just helps. Oh, and I forgot the bang in the hashbang. So hashbang /bin/bash. And then what we'll do is we'll run a sudo command. So we can say apt get. So this is built into Linux. Update. So they'll update everything for us, or sorry, they'll update the list of things that we need to update on the Linux distro. And it's good practice to do this at the start, just to make sure all your packages are up to date when you create the server. And then you can go ahead and you can actually upgrade all of those, and just put the Y flag there to upgrade everything without confirmation. So then what we want to do, now we've just handled that basic stuff, and you will probably put this on all your packages, on all your EC2 instances. So you can easily do that. Then what we'll do is we'll run a sudo apt get. So we can go ahead and we can install Node.js and npm, because we're going to need to run our Node or our NestJS application. And you can see here, I've got the NestJS application. I've run a npm run build, which created this dist folder. This dist folder has a whole bunch of files in it. What it doesn't have in it is a package.json file. So you could change your build script to move the package.json file into the dist, but you need that to run npm install. So we definitely need npm. So we have all the packages that we've used in our application. And then we need Node.js, of course, so we can run node main.js, so we can run that file. So we'll go ahead and install those. And then what we'll do is we'll just make a directory. And on our home directory in Ubuntu, which is Ubuntu specific directory, we might just create a folder called NestJS API. So let's just go ahead and launch this instance. And it happens pretty quick. You can see that it was already successful. And then we can click on view all instances. And it might just take a minute or so just to, it's just in the pending state. So it just takes a second just to set up. But here we can see the state of it. So there's a status check and that'll come up as and when it starts running. So now we can see that it's running. Let's go ahead and click on the instance. And there's a whole bunch of information here. So basically, now that we have our instance created, something to keep in mind is just because we have our EC2 instance created, this instance, it also, just like the user needs permission to be able to create the instance needs permissions to be able to perform certain functions. So for example, our server, our EC2 instance, we might want to connect to a relational database, or we might want to retrieve an asset from S3, or we might want to save to a file in storage, for example. And to do that, we need to create an IAM role. So we actually need to go to IAM, because what's happening there is the EC2, like everything in Amazon, basically you don't get any permissions out of the box, and that's for security purposes. So you have to turn on the permissions, and that's great because you wouldn't want to just accidentally allow everything if you only wanted a small subset of like things to happen. So what we can do is we can just go to IAM, and in IAM we can click on roles, and there's some default roles, but we can create a role here for a AWS service, and the commonly used ones at the very top is EC2 and Lambda. So we're using EC2. So this is a very common thing, and we'll just click EC2. And then what we want our EC2 instance, basically, we want access. Well, you'd want to select the access you have. So maybe you want to access S3, for example. So you'd click on Amazon S3 full access, or whatever access you needed, the limited amount that you needed. But for demo purposes, I'm just going to go to EC2 full access. So that will allow me to do everything in the EC2 instance. And let's just give this a name. I'm just going to call this, say, EC2-full, all caps, doesn't have to be. You can give it a description, I'm just going to use it. And this is the policy I was talking about. This is just a JSON file. It shows you the version, which you don't change that. That was just created, the latest version by Amazon, which is 2012. They didn't really need to update it to a later year or anything like that. There's a statement here. It has an effect. So this can be either allow or deny. In this case, we're allowing the particular action and service. So the action is we're assuming a role here. And in the principle, we have the service. So we have the EC2 service. So for the EC2, we're allowing full access. And we have the permissions policy here, and we can add a tag. So let's just go ahead and create that role. And now that role has been created, we can add it to the EC2 instance. So if we go back to the EC2 instance, click on that, and we look at our one instance that's running, we can click on that NestJS API, which at the moment is just a Linux Ubuntu server with nothing on it, other than a directory that we created with nothing in it. But what we can do here is we can go to Actions, we can click on Security, and click on Modify IAM Role. So now we can click the EC2 full. So now this EC2, and click Update IAM Role. So now it has the ability to basically do everything. So similar to how we have the IAM roles, we can also have what's known as security groups. So now our EC2 instance can interact with all of the services because we've got full access, but we still need to come to this security section here and allow for some rules, because by default, we've got, say, we've got port 22 and port 80 here. So we're allowed to SSH into it, and we're by default the server will be running on port 80 here. But what we want to do is we want to, because we know that our node or our NestJS application, if we look at the source code here in main, we're running on port 3000. So we need to expose that port 3000, because by default, nothing really is except for the minimal thing. So what you could do is you could have a reverse proxy which went through to, well, you wouldn't use a HTTP, but you would go from the default port and then port your request to your particular server application, which will then run that for you. Probably you would do that for real. But for our case, we're just going to go ahead and we're going to add a inbound rule. So if we click on the security groups here, it will take us to the inbound rules or the outbound rules. So outbound rules, we've allowed all traffic, and that's by default. By default, outbounds for all, but inbounds restricted. So we've got SSH here, HTTP here, and then if we edit the inbound rules, we want to add a rule. So we have a custom TCP, and we want to add it for 3000. The source is, we can specify that. Specify the source IP address or the range which you want to allow. So we're just going to allow anywhere basically. So we can just click on 0000/0 for the range or the CIDR blocks, and that will change that to anywhere IPv4. So, and you could have a description if you wanted, but I'm just going to save that rule there. And now we can see we've got 3 inbound rules. So we're able to SSH into the server. We set up HTTP, and we've also got our custom endpoint here for the 3000. So with that set up, let's go ahead and SSH into the server. So I'm just going to use the terminal in VS Code here, and I might just make it a little bit bigger here so you can see. What I'm going to do is I am in the directory one before the application. So I'm in a directory called EC2 simple, and I have my NestJS application in API folder. I also have my NestJS key here. So if I was just to run a ls-l command in git bash, we can see we have the permissions here. Now the permissions, they need to be the key, they need to be, or the PM file need to be 400. So you might want to run just a chmod 400 so the owner has full permission and the group and everyone else don't have permission to read. And then you can just do that for the nestjs.pm file. So now that that's done, what we can do is we might want to SSH into the server. So what we'll do is we'll run SSH, and then we want to SSH into the server and include, rather than type in the password directly, we want to have a inclusion of the NestJS file here, the PEM. And we're going to log in as the Ubuntu user. So when you create the server, you create it as root. We want to create it, we want to log in as the Ubuntu user. So basically, if we click on our instance here and we look at this here, we need to look for the public IPv4 address. So, oh, sorry, the IPv DNS. So, where is that? Oh, so that's just here. And I'm going to copy it rather than clicking it, because when you copy it, I think it gives you HTTP before it or something like that when you try to open it here. But since we're doing HTTP, we will just need to make that tweak. So we are logging in as the Ubuntu user at that particular IPv4 DNS, which for our case is this here. So if we do that, we should be able to log in, and then you can just click yes here. And then it says it will permanently add that key. So now we're actually in the server. So let's just do a quick ls. So from our command line, we're in the EC2 instance that we just created. So if I ls, you can see that there's the NestJS API folder that we created before. If we go back one or back two, this is our root. So we can see these are all of the folders that come with a Linux distro or the Ubuntu distro. So we have our binaries, we have all sorts of, you know, all the standard Linux folders there. So I'm going to cd into home, and there's a bit of a delay. So I'll just type in ls, and then we can see that there's a Ubuntu user, which is created by default for the Ubuntu server. Might be slightly different if you're on a different distro. And then we can see that we've got our NestJS API here. So we're logged in as the Ubuntu user. And if I just do an LSL here, we can see that the NestJS API was created as a root. So what I'll do here is, firstly, I want to change it so that, well, let's see. I want to change it so that we add the +W so we can have the right command. So we're able to do that. So home, you can either do it like the full path, which I'm doing, or Ubuntu /nestjs/API. So if we do ls -l, oh, we already had that because we set it up like that. So we got the right, so we're able to write there. And now we can go ahead and we can actually change the permission. such that we are going to have the Ubuntu user as the owner. For that NestJS folder there. If I just do a LSL here, we can see that it's changed from the root user to the Ubuntu user. And that's important because what we want to do now is we want to do a file transfer, and we want to do it logged in as this particular user. So what we'll do is let's try and transfer our API over. So basically, finally, this is our NestJS application. You run an npm run build. And right now, just to show you, all this is the standard NestJS application. So if you just go nest new API, for example, it will just build the basic hello world one. So we can see we got this controller here, and it's just giving you back hello. So you just got to build that, and then it'll create this dist folder. And we want to move all of these files over to the server. And we also want to move the package.json file over to the server. So like I mentioned before, you could change your build command to include that. But I'm just going to do it like this, and it will demonstrate how to move both a file and a folder over to the server. So basically what we want to do is we want to run a command for file transfer known as SCP. And we want to go ahead and we want to include the NestJS PEM. So that's our ability to SSH into the server. And basically what we want to do, let's firstly move the JSON file over. We're already in this directory, EC2 simple. So to get the we want to go into the API folder, and then we want to go ahead and get the package JSON file. And we want to be logged in as the Ubuntu user. And I don't know if I still have this in my buffer, so I'm just going to copy this again. So we're logged in as the Ubuntu user. That's why we changed the permissions just before to the Ubuntu. So we'll actually have access to write to there. And we can go ahead and we can just say, right after this, we need the location. So we'll say, okay, we want to put it to the home, to the Ubuntu folder, to the NestJS API folder. So let's go ahead and run that. And we can see that that's loaded. If we go back to our server now and run an ls-l, well, firstly, let's cd into the folder and then run an ls-l. We can see that we now have the package JSON file in the NestJS API folder on the server. So that's awesome. So we want to do the same thing, but for a folder this time. So that means I'm just going to tweak the command. And just after this nestjs.pm, I'm going to put a -r. So that will recursively do it for all of the files in the folder. And rather than moving the API/package.json over, what I want to do is I want to move the API/dist folder over. And since I want everything in the dist folder, I'm going to have a /* here. And then the Ubuntu command's fine. And the rest of the command's fine. So let's go ahead and run that. And this time there's a few files, and you can see that it's working and it's moving all the files over into our server here. So let's go ahead and just check that. So let's just run an ls-l. And we can see that we have all of those files there now, including the package JSON. So let's just go ahead and just check that we actually have Node installed. We did that before, and when we were configuring the application, that's the EC2 instance, and we can see that we have Node installed now. So now what we need to do is we can just run an npm install. And what's that? That might just take a moment, but that's just going to create all of the Node modules onto the server. And you could potentially move the Node modules from your client, your local client, to the server, or your local computer to the server, I should say. But the thing is, you don't really want to do that because it's really large and you don't want to move large files over the file transfer protocol. So it's better to just install it on the server itself through the package.json file. So let's just give that a moment to load. Okay, so now that npm is installed, we can just go ahead and we can just run node on the main.js file here. And then we can see our application is running. If we just go over to here, we can actually get the public IP address. I'm going to copy it because we're going to need to go to HTTP. If I go to HTTP / this number here, /port 3000, and I go there, we can see that we've got our Hello World application served through our EC2 instance using AWS. So basically, that is the video. In the next video, what I want to look at is storage, in particular, how you would go about deleting files. Like if you terminate your instance, you don't want to lose files and stuff like that. So I'm going to have a look at storage. And of course, this is going to be a series. So I'm going to show you everything a developer would need to know at the developer's level with AWS, specifically for NestJS and Node servers. So if that's something you're interested in, please subscribe to my YouTube channel. Thanks so much for watching, and I'll see you in the next video. Cheers.